Okay, welcome back. I think this is where we left off in the last video. Let's make a tuning board for the back of our head here that will accommodate, some tuning stuff. And I'll get started with that by making a new part. Let's go with there we go. We have a symmetric there. So now we're nice and symmetric about our origin. We just have to add, a few dimensions. So actually, let's sketch fillet this before I add too many dimensions. So we can add a fillet there, apply, and then here, apply. And of course, it just adds an equal relation so that our first sketch fillet determines the size. And we'll close that. Now, let's change this radius to maybe 0.125. Again, I'm working in inches because I have projects in both units. Let's go to dimension. We'll give this an overall length here of maybe 0.825 or 0.825 rather. And I'll choose an equal relation just like that. So it looks like, when I've added my sketch fillets, the symmetric relation that I added has been not there anymore. So I'll go ahead and re-add that. We're going to say there's our line of symmetry and there's our 2 points to be symmetric. We'll do the same thing over here. And now we're fully constrained. I would like to add a circle. And I'll add a dimension maybe from this edge. We'll go 0.254. And then I'll add in just a relation there, 0.4125. I think that'll be all right. Next, I want to push this out a little bit. So we'll just have a little bit of a different profile. And what I'll do is take this, right click, and convert to reference. I'll grab an arc. And then I can add a tangent arc. I'll go with vertical. Oh, looks like we already have that though, so we don't have to worry about it. I think due to the, tangency. So what sizes of arcs are we looking for? I'm going to make this 0.35. I'll make this radius 0.05. And then we should, be coming out like that, right? So we'll deactivate the sketch, and then we should be ready to extrude. So let's do an extrude. We'll go to a depth of something like 0.05, right? Real thin plate. And then we can move on to the next part. And that would be, how about a simple rectangle, right? So we'll say that this plane is the bottom face of our plane, or I should say our tuning plate. And I'll activate a sketch down here. So I'll convert a reference figure right here, and that will give me a nice edge to reference off of. And you can also add that in just with the relation, right? Now we'll go dimensions, and we'll make this 0.275 and then 0.05. You can also make that like sheet metal, right? If you had Alibre Design Expert and start making this as a sheet metal piece with this being a bend. But I think what we're doing here is just fine. Next, looks like I did not maintain association. So what I'll do is highlight these 2 points and say coincident, right? And then just to even things out, we'll make this horizontal. And you don't actually, Alibre doesn't fully define a sketch if a construction line isn't fully defined. So we're technically fully defined here. And how about I extrude? And let's do a depth of like 0.3, 0.3. And then I have to select my sketch. There we go. All right, so we have that. Next, let's do another sketch. In fact, let's choose this inside face. You can do either one. And then from the origin, we'll make this hole something like 0.23. And this could vary depending on your design intent, right? It's with real design intent, it may be more important to go off of this face. So, it's just something to keep in mind, depending on what you intend everything to fit together with. Next, I'll project a reference figure. How about this guy? To my sketch with maintained association, right? That's right where this arc ends. So if I reset my view, I can reference that point, and I'll give this a horizontal dimension of 0.257. That looks about right. And then what diameter? How about 0.09? It's not very thorough to just add a hole right there, but I think for the level of our assembly and what I intend to portray, this gives the user the tools for what they need. We'll do an extruded cut through all now. And let's do a mirror. So we'll mirror this extrusion and that extrusion, both those extrusions, across the ZX plane. And there we have it. So those are mirrored. I think that is going to be an adequate tuning plate for now. We'll have to add in some screw holes for some really small screws to hold this in place, but we can do that a bit later. Let me save that. So I'll close this part now, and here's our assembly. Let's add the tuning plate that we just made. There we go. So we're going to say new constraint. We'll line these two faces up, flip this guy around, and then we'll take this hole, and maybe I'll start right there, right? And that looks good to me. Next, we'll want to have a spur and worm gear. So let's talk about how to get a worm gear in there. Now, you can model one. Quite difficult, but it's possible. I want to cheat here and use FreeCAD. FreeCAD is pretty good with gears. So if you're interested in FreeCAD or want to follow along and you don't have FreeCAD, which would be incredible because almost all my stuff is in FreeCAD. Here you have freecadweb.org. You can go to downloads and you can download Windows, Mac, or Linux. And I imagine you're using Windows because Alibre is a Windows software. You can also go to the development versions on the FreeCAD releases page. Version 019 is an excellent version. It's really good, and it's open source, so you can get this for free. It's trustworthy software. I use it almost every day. So let me open up FreeCAD. I think I'm using version 018 here. Yes, I am. And I'm going to create a new part over here. And in fact, I heavily recommend going to version 019 because this will be a whole lot easier for you to do so. So in version 018, you may have a broken add-on manager. So you go Tools, Add-on Manager, and if 3D Printing Tools is the only one showing up, go to version 019, the latest version, and this will have an option to install something known as FC Gear, or the Gear Workbench. I already have this installed through other means. So here is the Gear Workbench. I want to create a Spur gear, right? And that really is as simple as just clicking the Spur gear button. So I click on my involute spur gear, and I can go through a list of parameters that I want the spur gear to meet. For instance, I would like my height to be 0.25 inches instead of 0.2. And as I change that parameter, my gear, which would be better if I had it more of an isometric-ish view, updates to that 0.25. Now my module, which is also pretty important, I'll leave to 0.04, but I want my teeth to be 10. So I'll update my teeth to be 10, and that's starting to look like a pretty good spur gear. I can go to my sketcher workbench now and create a sketch on my face. So, and that's just as simple as going into Sketcher and creating a sketch. Again, if you're watching this, you're probably familiar with FreeCAD. If not, I've got a lot of videos that cover how to use FreeCAD in depth. But here we're making a sketch just like in Alibre. So I'm going to start by making I clicked on my polyline button right here. And I want to add a symmetric relation, right? And so just like in Alibre, I can just click point, part of symmetry, and other point, and now we have a nice symmetric relation, just like in Alibre. And now I click these two lines. In fact, I'll hit the equal button, and there we go. Now we've got two lines. I'll make a center point arc from here down to here, and then back to my polyline tool. And then we'll go back to the center point arc tool, which is right there. Bam! Just like that. Now we're going to say equal, and I'll choose these two lines and these two lines. So now all of these lines are equal. I'll choose vertical here. And we're getting there. I'll choose equal again to make these two lines equal. And then I think it's just down to dimensions. I'll choose a horizontal dimension from up here, and we'll make that 0.002. We'll choose a vertical dimension here, and I'll choose how far apart I want these to be, and we'll say something like 0.023, or sorry, 0.23, there we go. And then I can choose a radius dimension right here, and I can say I want my radius to be 0.255. And actually, I was thinking in terms of diameter, so I'm just going to divide that by 2, right? And now we'll close, and then we'll do a Boolean. So we'll come over here to the part workbench, and I'll choose Extrude. And maybe I'll make this 1 inch symmetric, maybe 2 inches symmetric, just to see that this goes through. So we'll apply and close that. And now I have this option in the part design where if I click on my gear and then I click on the extrusion, I can choose this blue and white circle that says make a cut of 2 shapes. So I choose that, and there I have my final gear. So let's save that. File, save. This will be available on my GrabCAD account if you'd like to download this. I also will select my gear and choose to export my gear into a step format. I'll call that Spur gear. Save. Right, so there's a step file now that represents this Spur gear. We also want to have a worm gear for when we go to tune things. So I'm going to go back and create another gear, and I'll click on worm gear, which is 1, 2, 3, 4, 5, the 6th option in. And notice I get a nice 3-tooth worm gear. So I'll highlight this, and let's do a few adjustments on our worm gear. So for our teeth, I want to take this down to be a single tooth worm gear, and I'll hit the little refresh button up here. That will turn it into the 1-tooth gear that we want. We don't care about reverse pitch. Our module's good. Our height, I'll take it up to 0.5 or 1/2 inch. So I've got a bit of a longer worm gear now. Head is good, diameter is also good, and clearance is good. So I think we're actually looking very nice on this. So let's save this. And we'll save this as a worm. And we'll also export this as a step file. We're going to say export. I have step pre-selected. And we'll export that as worm.step. So I've got several gears. Let me pull Alibre back up. Now again, this is just working in the hobby license. You don't need a special super fancy license to import step files, and we can use that to our advantage. So the first thing I can import would be let's go with my Spur gear. That'll be pretty easy. So we're going to say insert design. Now if I try to import my Spur gear, where I stitched a solid, I can have several options like heal or making tolerant. My imported body is right there, right? So there is my step file that I exported out of FreeCAD and to Alibre. One of these days, I know you can get an involute profile in Alibre. You have to do some interesting things, but I'm confident I can. So if there's enough interest, I'll show how to model an involute spur gear in Alibre. Let's go with new constraint here and make sure that we're oriented right. Looks like we are. So I'll select that. We're going to go with a nice concentric right there. And I really like that when you have dynamic parts in Alibre, you can just click and drag. That is such a luxury. Let's now work on our worm, and I want to make kind of the tuning knob onto our worm as well. So for that, I'll open my worm instead of importing it, and I'll heal, make tolerant, whatever. And by the way, if you do have any visibility problems, oh, and actually I just opened this up and there you go, right? Visibility problems. So if this happens to you where an imported part isn't showing up, it's actually pretty easy to work on. We're going to go to our View tab. We're going to customize performance. I'm going to take my facet resolution, drag it all the way to coarse, or if it's already on all the way coarse, you can drag it to some other setting, say apply, and then it shows up. And then I'll just drag it back to my previous setting, apply, and first off, look how much finer that became, but next off, that was a pretty easy solution. So what I would like to do is make a sketch, how about right on our YX plane. So we're going to say Model, Activate 2D Sketch, and I'm going to create a circle right on my origin. We're going to use a dimension and make that about 85 thou, 0.085. For some reason that's in millimeters because it came from FreeCAD in millimeters, right? So I'm going to say, well, if I can type 0.085 inches. There we go. A lot of my FreeCAD projects have become metric. Let's go with Extrude. We'll go dual depth. And how about we have this side be 0.75, again, inches. And we'll come over here, 1.25 inches. That's the length that I want. And then, see, this is the rod that our worm gear will spin around. I think I'll need a spacer to put in our prongs, so I can just model that right in here. Let's say create a reference figure to here. I'll maintain association, and I'll choose a vertical relation between these points, and then I'll go to a horizontal relation between this and the origin. Let's go with a dimension of 0.116, And of course, I need to change this document to inches, but I think I'm almost done, so I think we'll be okay. And then 0.065 inches. Let's deactivate. We'll do a revolve. And I actually need to choose an additive revolve. Will be much better. And we'll revolve around that axis, right? So we click on this axis, we revolve around it, and that's looking good. Now, I think we'll just add the tuner, cut it to the right size, and we're done. I'll activate a sketch on here, and I'm going to make a line. In fact, let's focus on using the sketch mirror here. I think that would be very efficient. I'll choose an arc. Of course, I chose a center point arc, so I'll put the center right on that center axis. We're going to go horizontal from here to here. We'll add in a dimension and make sure that this is radiused properly. I want to go 1.25 again inches. And let's go from here to, nope. I want to have an angle. Can I reference this for an angle? If not, let's grab the center line. And that's just as easy. From here to here, we'll take an angle. Let's say 160 divided by 2, or an 80-degree angle. So you have 10 degrees off horizontal on either side. When we go to mirror this, I'll take this point and dimension it relative to my origin. We'll say 1.211. Of course, I would like that to be consistent with my top level units. I really should be changing my units, but I'm almost done. I can taste it. From one side to the other, we're going to say 0.75. All right, finally, I'll give this a height of 0.35. All right. I'm sure I'm driving someone crazy by typing in my unit instead of adjusting it. Let's determine how wide we want this to be. All right, so we've got our center point here. I'll grab my origin. Of course, you have to hold Shift when selecting multiple things. And I'm going to say vertical. So this is our... It says this line is lacking magnitude. Ah, there we go. We just need a little vertical relation. Let's go with a line. Actually, we'll just mirror. Mirror here and here. We'll mirror about our axis. And we're fully defined. So we'll deactivate. We'll do an extrude. Let's say mid-plane. And we want to go to a depth of 0.125. Okay, and this should be our last sketch down here. And I think it should be pretty easy. We'll grab our XY plane, or YX plane, no matter what you call it. And let's try to make this as easy as possible. I'll import a reference figure. I'll import, how about just that edge, maintained association. And let's go with an arc. And it's so nice for Alibre to be able to allow us to grab the center point so easily. We'll add a dimension here and say, how about 0.02 for our radius, right? Nice small radius. And then we'll go to line. We'll go to tangent. We'll go tangent arc. And again, how I'm approaching this is really dependent on the engineer's design intent. And there are pros and cons to what I'm going to do. Let's go with, vertical. Perfect. Next, we'll add in a horizontal relation from here to here. So I'll grab in my arc endpoint and this point here, and we've added a horizontal relation, which is what we want. And then what kind of radii are we looking at? Maybe I'll just dimension this. From there to there, we'll give a horizontal dimension of 0.15. Okay, so here are the pros and cons of what I'm about to do. The pro is that I'm doing a lot less sketching by just doing this in 1/4. The con is I'm going to have 2 more items in my history tree to recompute. So what I could do is mirror my sketch to the other side and do 1 mirror, but I'm going to do 2 mirrors instead and just do 1/4 of this. So I'll do deactivate. I'm going to do an extrude cut. So I'll specify to depth. We'll reverse and just type in, something big. Hey, I thought I reversed that. So we'll edit, reverse, okay. Right, now is the fun part. I highlight my extrude. We'll do a mirror. We'll mirror across this plane and say okay. We'll do another mirror across this bottom plane, and I'll also select my original extrusion, and there we have our knob. So we'll save that, and we'll save that as our worm, and that will save it in a nice Alibre format for us. So importing and editing step files is really easy with Alibre, and that makes it quite advantageous. I think I'm going to angle my tuning plate to be kind of parallel with this face here. I think that will make for a pretty good look on the guitar. I could possibly flip this all the way around, but I might get some interference, so I guess I wouldn't get an interference if I were to continually, pattern it. Okay, let's try doing it like this. I'm sold. Let's insert design. We'll insert our worm gear now. And there we have it. New constraint. We're going to go there, and I'm going to flip sides so that my tuning knob is on top, and accept that. Now we're going to go there to there. Excellent. And that fits about perfect. So we'll close that. Alright, so we've got a pretty good mesh on these gears, and I think we're looking good. So I'll create a new constraint. So I'll choose this face, new constraint, and this face. And we're actually going to say 0 degree angle, and that means parallel. So we've added one of these. Next, I can actually duplicate my part. I just hold Control, and then I click and drag, and I can duplicate these all day long. And that's a super nice feature that Alibre offers. Let's go with a new constraint there to there, and coincident, right? And then we're going to say, coaxial. Now, that's a pretty good fit for tuning plates, I think. And then from here to here, we can choose that. Oh, looks like coincident doesn't work. So we'll choose an angle of 0 degrees. So that should be fully defined. I believe it is. Yep, this will still move on us. So I'm just going to finish adding all these parts, and then we'll proceed. I won't make you sit through this because you may or may not be trying to do this on your own pace. Alright, so we got these all together. And there's a few in-context designs that I think would be pretty good to add, right? So in real life, we'd probably have some slack from here to here, and anyone would be able to question how this would be put together in real life. And I've got so many projects that I'm working on in addition to freelance, my full-time work, multiple CAD projects for the channel. At certain times, I'm going to be clear. There comes a point when you say enough detail is enough detail, and this is enough for me. So I'm not going to worry about actually putting this together in real life. I think for someone who's actually doing a guitar design, this would be pretty easy and intuitive, and I think I provided enough information to get over the concepts of doing this in Alibre. So let's do an in-context edit. I know I've done this before, but since not every CAD modeler is capable of in-context stuff, I think it's very good. Let's activate a 2D sketch. And this is, again, editing the part and not the assembly. I'm going to reset my view twice, and that will take me to the side that I'd like to look at. Make a rectangle right on the origin there. And I don't think dimension... Oh, yeah, we'll grab that edge. But I don't know if I can go... Yeah, there we go. Let's go maybe 0.01. Yep, that's maybe 5 thou. Right, maybe we'll make that a real tight fit. Well, okay, 0.01. Well, we don't want to have too much slack, but the string tension would pull, at least it should, pull any backlash out of the gears as well. We'll go precise, 0.005. That's kind of a tough decision on how you'd want to gap that. We'll go a bit higher, maybe 0.07. We'll deactivate. We'll do a revolve, an additive revolve. And our axis should be a no-brainer. There we go. That center axis there. And the cool thing is, I'll go to my top assembly here. We're going to say Edit Part Subassembly. And now all of our worm gears that we've added have the same addition. It updates automatically. We edit one, all of them change. Now we're going to have screws that will hold the tuning plate to the back of the head. So again, all I can edit here, right? Make it pretty easy. We'll activate a 2D sketch on the face that we've selected. And let's project, we'll say create reference figure here and here with maintained association. And we'll come down here. Let's add some circles depending on what screw size you want and what your head shape and everything is. This might change. You might want to stick them more towards the corners. So keep that in mind. You don't want to have the head of your screw intersect with our gear, our spur gear. So these holes are equal. We're going to say dimension and 0.0625 maybe. And then I'll add in another circle. We'll put it right on that axis. And we'll add an equal relation so that all these are equal. And we'll add a dimension, a height of maybe from this hole to this hole, because your hole pattern would be what's critical, 0.784, something like that. And then I do want this axis and this whole center to be coincident. All right, so we've done that. We'll deactivate, we'll do an extrude cut, and I think I have the luxury of saying through all. And again, that edited the part, not the entire assembly. And that extrude cut showed up on all of our plates. Now, the nice thing about in-context editing, and you do get complications, right? This can lead to errors when you go to edit things a certain way. So you have to in-context edit, in a way that makes sense. So we've saved everything. Let's edit our head. And again, in context editing does carry different aspects of things that are good and bad. So if I were to move my tuning plate, then the holes will move with it automatically, and that may or may not be desirable. So we're going to activate a 2D sketch on our face, and I want to project these 3 holes. In fact, I can go and click every hole if I wanted to. We'll maintain association. Another shortcut is I can actually project maybe a reference figure with maintained association. I'll grab a dimension and pull out my center to center dimension. 1 inch exactly, right? That's pretty easy. So I know that these holes are 1 inch apart. Let me select all of these, and we can simply do a sketch pattern. So we're going to say linear pattern. We're going to say linear path is going to be a line that, you know, runs symmetrical. We're going to say 6 instances, and we're going to change our direction. We're going to say OK. And these came in as being red, of course. So we have this linear pattern. Notice that none of these are constrained. So that could be a drawback. But linear pattern, if you need to make something quick and you're not worried about constraints, is an option. But I think a project to sketch with maintained association and just clicking these holes is probably more in line with my design intent because I can fully constrain everything. So I'll finish clicking these holes and then we'll create them. Alright, so we've made those, and then we'll deactivate and we'll do a cut extrude. Let's go to the right view. So we've gone to a depth of 0.25 in the wrong dimension, of course. We'll reverse that. Yeah, that should be deep enough for the screws. So you would want to make those a bit smaller so that you could tap them or something like that in real life. So I think that covers the tuning mechanism. We'll just need to come up with a post. I think I've been going on for quite a while. I believe I have. So instead, let's make the post the next time around. Thank you so much for watching. I hope this video was helpful. If it was, please subscribe, and I'll see you in the next one.